Right. Hello, everybody. It's really great to be here to talk about a super exciting topic, which is the future of developing games with AI. And I'm going to be showing you some concrete examples of how our company, Cosmic Launch, is building puzzle games using AI-powered technology. Before we go there, a quick introduction about myself. So, co-founder and CEO of Cosmic Launch. And I've been in the games industry for a long time, about 30 years, and 24 years of that in game development. So I've been mostly in technology product leadership roles in leading game studios like Electronic Arts and King. And what is really great about that is that those tech teams, they are usually central teams, and you get a chance to work with a lot of different game projects. So I've calculated that I've been part of more than 100 launch games, and that, of course, has given me an opportunity to see like what makes developing games, operating games hard, and what also makes developing and operating games easy. Okay, so the key messages in my presentation, they are that, yes, AI is really changing how games are developed, and it is a big part of the future of game development. So my recommendation to everybody here who's working for a game studio is that you should be getting your teams and technology ready for AI. The approach we have taken at Cosmic Launch is that we have built our own in-house AI-powered tech stack called Puzzle Engine for puzzle game development. A little bit about the company. So it was founded 2022, and this was really before the AI boom started to happen. So the purpose for us founding a company, it was really about having several veteran game creators together talking about what would be the much better ways to build much better games. And when we started sort of thinking about what the solutions are, that's when we sort of started seeing okay, there's a lot of new AI models and AI services popping up. And very quickly we realized that, all right, AI can really help us solve those problems. So AI became as part of the solution, and that way it also became part of our DNA. And if you think about the timing, I would say that our timing was really perfect because we sort of started looking for solutions, and once we saw the solution from AI, we got a pretty good head start of starting to develop games using AI. Okay, founders, we have 6 founders, super veteran team, average experience in game development, 15 years, working on more than 10 top-grossing puzzle game titles. So we know how to design, build, and operate these kind of games. And we have also done previous exits of technology and studio exits to Disney and Playtika. And we have currently 20 developers in 3 locations. Helsinki, where is our headquarters, in Oulu, which is a city up very north in Finland, which is, by the way, the world's most northern game studio street address with that office. And then also in Stockholm. So our approach, what we do, how we build puzzle games and use AI-powered tech for that, is that Puzzle Engine, our in-house technology, it enables game designers to use no-code toolset to generate a lot of different core game designs and also marketing minigame designs and also market test them. And once we are then with the market testing finding new high potential puzzle genres, we want to use the first mover advantage and be the first company of creating a game on that genre. And then when we go into the operations phase, we are then generating levels and live ops content like 10 times faster using our AI-powered production line. Okay, so soon we will get to the AI use cases. But when I'm talking about AI, I'm mostly talking about that in the context of Puzzle Engine. So it's our in-house technology. So this looks like a sales video. It's not. So we are not licensing the tool. We are pretty selfish in that way. We just have all the goodies of Puzzle Engine ourselves. But it gives you the context of where we're using AI. So let's check out the video. Okay, so that was a quick overview of what the Puzzle Engine does. And now let's talk about using AI with Puzzle Engine. Let's start with the technology side. And there's 3 principles we have used in how we integrate AI to our technology. The first one is super important. So ability to add and remove AI models. So we are not building the AI models ourselves. We are using AI models from different partners. We do train and tune them for our purposes, but we are really focusing on the application layer. But this is important for us because AI field is changing really fast. So some model which might be the best one this month for some specific use case, it might not be the best one in a couple of months. Also, the legislation might be changing. So we thought that it's a really critical principle for us that we are able to do the integrations very fast. Here's one anecdote now that this is a Google event. So our CTO a few weeks ago did actually an integration to one of the Google Vertex AI models, and it took him 30 minutes to do it, and I was pretty impressed. But that's what he really designed our architecture for. Second thing, which is maybe less of a principle but more an architecture, this is actually where we differ a lot how other companies who are building puzzle games do their game architecture. So puzzle games, you need a lot of levels. And so every company is, of course, not hard-coding the levels. The level data is in, you configure levels, so that's in data format. But we also do that, but we also have the game mechanic, like what are the rules of the game, like how do you do matches, or if you do matches, or how you do interaction in the game. Also, that is a configuration for us. And that gives us a lot of advantages, I'll show later. But one of the advantages is that you can actually expose how the game works to AI or in machine learning. And when AI can see the sort of correlations of actually game logic, not just what is the level design, it can make better recommendations for example, level creation and optimization. The third principle that we thought is really important for our teams, especially the non-engineers like level designers and artists, that they don't really need to think about the complexity of using different AI models. We wanted to design end-to-end workflows for them, so designers can really do pretty much all the things in Puzzle Engine, and because that's how we sort of hide all the complexity behind the tool set or the tool UI. And we also enabled them to create their own workflow templates, so they can actually, so when they generate levels, or if they generate art, they can actually do a template for certain use case for themselves. All right, so now let's go into the actual use cases. So let's start with AI in prototyping. So why prototyping is important for us is that well, every game company is full of a lot of creative people, and the creative people, they have a lot of ideas about games. The challenge, of course, always has been that how do you know if some idea is good? Is there hit potential in that idea? And it's really important to be able to see the idea in action. And typically companies, the designer has an idea, but they need an artist, they need an engineer to try the idea, even internally, and then later, of course, externally market testing. And so we wanted to enable it super easy for designers. They can actually come up with ideas, create a prototype just with Puzzle Engine without an artist or without an engineer. So here's an imaginary situation. So let's imagine that our game design team, they came up with a potentially fantastic new game idea, which they call Angry Dev. In this imaginary game idea, it's about a coder, Angry Dev, who's developing code. His code is very buggy. He's getting very angry, and he's starting to throw anything on his desk on the code to get rid of the bugs. I've seen actually some engineers do that. And now the designer can just go to Puzzle Engine and then start creating the game. So in this, what is seen here is that they start creating placeholder art assets. They can use already existing templates of, like the AI use cases, generate art. They can select what style, so in this case, cute style, and then they just describe the object that they want to use. So in this case, it's a software bug. And then the AI is making, presenting different options, and then the designer can pretty much just drag and drop it to the prototype. Designers can then just continue this by generating rest of the assets, art assets they need for the prototype. So far they didn't need an artist, and they don't need an engineer either, because they can also configure the game logic from the Puzzle Engine UI. There's also an embedded level editor in Puzzle Engine, so they can pretty much put together the whole game prototype in actually a few hours. So I'll show you a video of what Angry Dev prototype looks like. It's actually prototype I did myself just for demonstration purposes, and really took me 5 to 6 hours to do this. So this is what Angry Dev looks like. So Angry Dev is throwing all these items on the game board, and every item has a different sort of configuration. Some of them do like a vertical effect, some of them do horizontal effect. And here the player is trying to generate bug-free lines of code, and then that's a match, and that's what happens in the game. Like that. And then, of course, when the bugs are gone, you have a happy dev. All right. So is this the best game in the world? Maybe not, but that's exactly the sort of purpose of prototyping. You want to try what your idea feels like, what it looks like, and then decide if you're going to take that further or not. All right, so that was prototyping. So all the art was generated by AI, and when you do a prototype, there's a lot of placeholder art. So AI is pretty good of doing art for that purpose. So now let's stay in the art, generative art use cases, but go to the production. So actually making final game art, and that's a little bit different situation at the moment. So when I'm talking to our art team and sort of asking, where is AI really helping you to make the game? Everybody, it's pretty obvious that AI is excellent for exploring and iterating different ideas. You can do things that were not even possible before, which means that the art team needs to spend less time doing placeholder art, so all of their time can be used for doing the final art. So there's some areas where you can actually use AI already to produce, for example, backgrounds. I'm going to show you some examples. But then there are some areas where the current art AI is not yet good enough, but there's still a lot of benefit, like a productivity advantage that you get from using AI. So here's 27 images of a railroad. Why I wanted to show this is just to give a sort of example of, art team, they can, if they need a background image, so AI is pretty good already doing pretty, good looking 2D backgrounds for mobile games. So they can just generate loads of different ideas and then pick one they like, or even test them if they are not sure about that. But imagine a couple of years ago, you would have gone to the art team and say hey, can you draw really polished images of railroad, maybe a 30 of them? That would have been a really, not an easy conversation, because it would have taken a couple of weeks for them to do it. Now you can really do things that you were not even thinking about before. So that's a very sort of concrete change that AI is bringing for developing games. So now let's go into an other art use case, which is more challenging for AI. So AI is not yet there for keeping the consistency of, for example, creating characters. So you can't really use that for that so much. But if you are sort of designing your art production pipeline really well and thinking about how can you take the most sort of advantage of AI services, you actually get pretty good results. So this is something what one of our artists was sort of using as an example when she was thinking about what the pipeline is. Then after this, I asked, okay, how much was AI really helping you to go through this? And she said that about 70% of the work that she would have needed to do manually was done by AI. So even if AI is not there yet to do final character art, there's already a benefit if you find the right way to use it. All right, so now let's move away from the art, which is usually the thing that people are mostly talking about when you talk about generative AI. Let's go to level production. And so we are making casual puzzle games, and you need a lot of levels. Some of the games, they have 10,000 levels. So it's really, of course, it was an obvious problem for us to solve. how could we become more productive in generating levels? So one use case is AI-assisted level evaluation. And you might have seen the word assisted, AI-assisted, used in a couple of slides here, and that really reflects our sort of approach, how we think about AI. So we don't think that AI is doing anybody's job, like just replacing somebody. We are thinking about AI as helping our team members to do their job better. They can be more productive. They can do get better results, and that's also in level testing. So level testing. So you have an AI bot which is playing through the levels and then giving sort of results for the designers before they actually deploy the levels live. So think about like the comparing to like you need to put the game live or level live, wait for the results, and then realize that you have a too difficult level, or maybe the beginning of the level was too difficult, but the end was too easy. So like balancing, getting information about what is the balance of the gameplay on the levels. So super useful for level designers. Then we also hooking, we haven't launched our game yet, but what we are preparing to do is also hook the sort of business performance and player gameplay data into this level testing so that we can use the information about what kind of levels churn, what kind of levels monetize better. And then I mentioned about the architecture of, the whole game mechanics is presented in data format, so our machine learning can actually use also that to understand how to test levels better. And this is also embedded in the puzzle engine. So here is actually a video of AI bot testing a level. This is of course like actually it's much faster, but we slowed it down so that you can actually see something. Interestingly, also this level has been generated by AI. And I mentioned the integration with Google Vertex that our CTO did a couple of weeks ago. This is actually what we used it for. We custom-tuned one of the models to generate levels, and this is one of the levels that we generated with Google Vertex. So talking about the AI-assisted level generation. So again, it's AI-assisted level generation, so it's really level designer. We have 2 level designers, which is actually quite a lot for a team of 20. But they are working together with AI, and what they can do, for example, is that they can design few levels as examples themselves, then feed it to AI and say that do more of these. Or if they don't have enough examples, they can actually generate a lot of levels with AI and then pick the ones that they want to feed back to AI as examples. They can also configure guidelines for how to generate levels, so use only these elements in the levels that you are generating. And again, I mentioned that we did a custom-tuned model for this. This is really so special use case that you really need to custom-tune your AI models that you are using for level generation. We also do some procedural automation. So when you feed in the example levels for AI, Puzzle Engine is changing the format so that it's easier for AI to process it. And once AI is giving back the level designs, then Puzzle Engine is again processing that data and make it something that is useful for level designers to look at. And again, also here we are hooking in player data, performance data. What we are of course expecting when we expose to the whole game logic for AI is that AI can find correlations with some mechanics in the game with better monetization and less churn, for example. Last one here, output filtering with AI-assisted level testing. So what I mean by that is that now that we have AI level generation, we have also AI level testing, putting those things together. Think about a level designer coming to the work in the morning and seeing a list of recommended levels which has been generated by AI and also pre-tested by AI. So that's what we mean. And so if you think about all the sort of phases that are needed, all the steps which are needed for generating those loads of levels, there's level creation, level testing, level iteration, level optimization. There is a place for AI to make it more productive in each step of this end-to-end workflow. And it's really important for us that we are able to put them to behind sort of one tool set, so you don't need to jump between different tools when you work with levels. And then if you start thinking about the number of levels, if there's 10,000 per game, you multiply that with the games in your portfolio, you start looking at in pretty significant sort of advantage of the productivity lift that you can get from using AI. Okay, so last topic, last item here, which is using AI in marketing. So this would deserve its own presentation, so I'm just going to look at one very specific area, which is mini games. So you probably all, of course, understand what mini games are, but just as a recap, comparing to fake ads. So some companies are advertising, showing ad creatives which have gameplay which actually doesn't exist in the game. With that, you get a lower CPI, but then you take a retention loss when the players go to the game and they realize that there's nothing like that here at all. But enough, of course, people stay that sort of makes sense for some companies to do that. But of course, a better situation would be that if it's easy for you to add mini games, like those mini games that you are advertising into your game, and that is super easy for us with a puzzle engine, because it's the same sort of architectural difference we have is that you can just come up with different mini game ideas, and then you can create videos and test which ones are attracting the players the most, and then when you found it, you just add it to the game. It's really as easy as just adding a new level for us, because it's just content. So, okay, now minigames and AI in the UA context. So, I mean, the obvious sort of uses of AI here is similar to what we already discussed, like generating minigame levels with AI, also having a bot playing through the minigames and have automated recording of the gameplay so that you can use that in the ads. You can generate art assets for the ad creatives. You can also generate video. And if you take this a little bit further, you can, of course, have AI help analyzing the gameplay data, how players are actually playing these mini games, and feed that back into your creative process, so you can find maybe ideas that you were not thinking about, like what would be a better mini game. So I had a session with our head of marketing about this area, and we were talking about like where is he already using AI in the area of user acquisition, where does he see he will be using in the future. And he showed me a list of the things that he's planning to do and already doing, and that list was actually pretty long. And not going through all of this here now, but just wanted to also use this as an example how AI is really changing how games are developed and how it's sort of entering into all of the different aspects of games, including marketing. Okay, so this is pretty much the sort of end of my presentation, but I wanted to end this with making everybody think about a little bit like, okay, we are now in the future of using AI in developing games, but where are we going next? Or what is the future of using AI in game development? So I thought that I would maybe summarize this in one question. Can AI design games? Obviously, games are not made for, we are not making games for AI, we are making games for humans. But can AI design games? So we started thinking about that, and actually from technology perspective, with our architecture of the mechanics also being configurations, yes, actually we could train an AI model to generate new kind of game mechanics, and then we would be testing them with players. But that's not what we are planning to do at the moment, because that's not the problem that we think needs solving at the moment. So game designers have a lot of ideas, and the current bottleneck is really about how to materialize those ideas in prototypes so that you can see if they are good ideas and if they should be taken further. But I think this is an interesting question. So AI can generate levels. Can it actually generate game designs? And maybe this is something that we should visit in a year, maybe here, because AI is moving pretty fast and it's really entering into a lot of areas in game development, and it's really also opening up new use cases, like things what we haven't done before. So that's what I had to present And after this, thanks for listening. I'm super excited about this topic. Thank you. After this, we'll be taking a break, so 20-minute coffee break. So I think we all need a cup of coffee at this time of day. So thank you.